Hello everyone, my name is Sriharsha Dhanekula and I am joined by my colleague Farook here. Today we are here to demonstrate and provide an introduction to our solution for closed loop remediation using Crosswork applications. As a part of this session, we will be discussing about Crosswork applications that include Health Insights, NSO, Change Automation, Situation Manager, and Data Gateway. We will see how easy is it to integrate these applications together to form a full-fledged closed-loop remediation solution, and which is fully automated and very easy to use. With that being said, let's just give a thought about the market trends. In today's world, there is a huge increase in network traffic. There is a huge amount of traffic volume that is increasing rapidly. The size of the networks to maintain this traffic is growing, and service providers need to operate at a very fast pace to meet the demands of their own customers. And also there is a huge increase in competition among the service providers itself. Gain relevance in such situations, service providers need to execute at the speed of software. They need to turn up services so quickly that the time to market is very quick. Satisfaction increases, which in turn increases the customer retention, thus helping their business grow. These are the requirements of modern day networks. Cisco Crosswork applications are here to address this. This is one of the codes that has been made by one of the VP of operations of major service provider. He says there are like 100,000 labor hours annually on constant changes that are required in their mobile backhaul network. With our applications, Crosswork Health Insights and Change Automation, we can change the tasks from manual to automated, ad hoc to programmable, reactive rather than reactive monitoring to a proactive monitoring methods. With this, the projected savings is around, you can see the numbers there, that is around 7.8 million to in terms of dollars, when in terms of labor hours, we are talking about close to 95K of labor hours. With that being said, what are the various applications that fall under Crosswork? As you can see, Crosswork Network Automation is a suite of products or a suite of applications that include Health Insights, Change Automation, Network Services Orchestrator, that is NSO, Collection, that is Data Gateway, Optimization Engine, Network Insights, and Trust Insights. Typically, all these applications are categorized into two formats. One is on-prem applications and the other one is cloud app. On-prem applications include Health Insights, Change Automation, NSO, Optimization Engine, Data Gateway. Currently, we categorize them as on-prem applications, whereas Trust Insights and Network Insights are our cloud offerings. When it comes to Situation Manager is an OEM product of Cisco. Okay. As a part of this demonstration, we will be talking about Health Insights, Change Automation, Situation Manager, NSO, Data Gateway. So, as you can see, this slide is pretty self-explanatory. This is a closed-loop automation maturity model. We are typically talking about different stages of this model, which include element focus, network awareness, model-driven, programmability, service awareness, intent-based, and self-healing. The intention of this maturity model is to help you grow your revenue potential, at the same time decrease the operational expense. With that being said, let's jump a little bit into what are Health Insights and Change Automation. Health Insights, a programmable closed-loop remediation system that drastically optimizes network performance and helps you improve service stability. In terms of closed loop, typically the steps that are involved here, it constantly proactively monitors the network, alerts whenever there is a breach in the SLA, and remediates it in order to restore the SLA back. For us to get there, we have concepts of key performance indicators, which fall under the umbrella of health insights, and playbooks, which fall under the umbrella of change automation. Okay? And these are pretty customizable, and these products are built with an API first strategy. These applications are based on telemetry, SNMP, and CLI collections. Let's give a little deep dive into health insights. What is health insights? Health insights is nothing but as the name suggests, it provides you an insight about the health of your network or your service, wherever you enable the key performance indicators. Typically, we collect all the data from your network and help you make the data actionable. Health insights comes with a certain set of KPIs that are out of box, and if something that is very exclusive to your network, you can write your own custom KPI. We have the whole universe of YANG paths available with health insights. If some YANG path is missing, you can onboard the YANG paths and then create your own custom KPI. We help you with alert and correlation engine. We forward all the alerts to any HTTP endpoint. We have a recommendation engine where we go take a look at the running configuration on the device, and depending upon the running configuration of the device, we would provide a set of KPIs that need to be enabled to monitor the health of the device. And these are based on SNMP, telemetry, and CLI based. We can also tie these KPIs to playbooks, depending upon how you want to resolve an alert that is coming in. What are the various features of health insights? We have a recommendation engine, as I just mentioned. We take a look at the running configuration that is on the device and then recommend a certain set of KPIs, which are nothing but a subset of out-of-box KPIs. We have zero-touch telemetry configuration that can be pushed onto the device. Like whenever you enable a KPI, all the respective sensor paths, cadence, templates, and everything gets pushed onto the device automatically. The alerts can be forwarded to any HTTP endpoint or any AI/ML systems. We do closed loop remediation. That's what we are going to talk about as a part of our demonstration today. As mentioned earlier, we have out-of-box KPIs and customizable KPIs as well. We provide you the rest of KPI profiles, statistical thresholding, and custom KPI wizard, and those things which come as a part of the functional or feature-rich health insights. What are KPI profiles and device groups? So I just want to touch upon these key factors here. So KPI profiles are nothing but you can create KPI profiles which you think are relevant KPIs to be enabled on a certain set of devices. You can group all the devices with tags, and then you can have all the KPIs saying that, okay, these are all my P routers. I tag them with P routers tag. And then this is P routers KPI profile where I want to monitor all the certain set of KPIs on these set of devices. So you create a KPI profile which says P routers KPI profile, which has, like, for example, in this case, let's say it has CPU and interface drops. So when you enable this KPI profile, it would automatically enable the KPIs which are a part of the KPI profile, that is nothing but CPU and interface drops automatically. You can create an alert group on top of this KPI profile, which typically is nothing but a composite KPI alert. So what are composite alerts? Composite alerts are nothing but you create a Boolean logic of the KPIs that are a part of this particular KPI profile. In this case, it's CPU or interface drops. Whenever there is an alert on the CPU usage, or if there is an interface drop, you would get an alert. A simple example is give me an alert when CPU is above 50% and memory is above 50%. That's when you would get an alert. So this is a pretty powerful tool to get the alerts and take corrective actions. So when I say corrective actions, what is that? So corrective actions are nothing but a set of configuration changes that you want to make on your device when an alert is coming in. So these configuration changes are driven through playbooks, and playbooks reside on change automation. Change automation is nothing but it's helping you to codify your workflows. Like as mentioned, it has these playbooks, which are, each playbook has a play in it. Each playbook has more than one or more plays in it, and each play is a task which are executed sometimes in parallel, sometimes serially, depending upon how you want to execute them to achieve your intent of config changes on the device. What are change automation functional or features? It helps you do a parallel playbook execution, so you can execute the same playbook on 10 routers at the same time. You can trigger it off and leave it there. We are, as mentioned, it's an API based ecosystem, so you can trigger off all the playbooks using APIs. We have workflow engine. We have pre and post state comparison, like you can define your failure policy, check before, capture the state before the start of execution of the playbook, and capture the state after the execution of the playbook, and then compare it, and then define your success criteria. And if the success criteria is not met, you can do a rollback where it restores to the previous state. We also provide you the option of scheduled deployments, like you can do certain changes like an upgrade during a maintenance window. You can trigger the playbook off and it would automatically get done during the maintenance window. No need to have staff like at the 2 a.m. in the morning looking at your scheduled deployments. As mentioned, whenever there is a failure, you can do a rollback. This is one of the great features of change automation, and it can be put as a part of the playbook execution strategy itself. Again, we have out-of-box playbooks, which are around 60 out-of-box playbooks, and you can customize your own playbooks as well. You can download the existing playbooks and make changes and re-import them back and run the playbooks depending upon how you want to execute it. We support 3 steps of execution policy, that is continuous, single stepping, and dry run. In case of a dry run, you can check, like for example, you have customized your own playbook and you want to check if if it's doing or if it is going to perform the steps as expected or not. In a dry run mode, everything is done except the config gets pushed onto the device. So it gives you an opportunity to check if everything is going as per plan or not. We have continuous and inline verification, which is running behind the scenes when you execute the playbook. We have detailed audit trials of every event that has been happening and occurred during the execution of the playbook, and these can be forwarded to syslog server, or they're always available on the change automation side of things. With that being said, as I mentioned, you can run certain tasks in parallel, certain tasks in serial in one of my comments for change automation. So in change automation, we have a concept called tags, which is continuous, pre-check, maintenance, and post-check. Any task that is tagged with continuous and pre-check is run in parallel. If there are more than one task, they can be executed parallelly, or they start off parallelly. When it comes to maintenance and post-check, they are executed in serially, one after the other. Okay, and we have the concept of verbs, which are used in playbooks, which would take away the complexity of your config changes that need to be made, and you can just do it in plain English when you're trying to execute this playbook. So how are we augmenting this closed loop? Whenever we say closed loop, we typically tend to collect the data using data gateway from the device, and then the collected data gets forwarded on from the data gateway to the northbound, which is health insights, where the alerting logic is run. And whenever the alerting logic is breached, or whenever an alert is raised, you want to take a corrective action. So typically, when we are collecting the data, we are collecting the data per KPI, and the alerting is done at the KPI level. So we can tie a playbook to the KPI saying that whenever an alert on this particular KPI has been raised, please run this particular action to fix this. So we form a closed loop by doing this. We give you this opportunity to tie a KPI to the playbook. A good example here would be, we would monitor the state of the interface. If the interface is flapping, we would run a playbook, which is interface state change, to shut the interface down. So it's a very simple and a powerful example. With that being said, in our demonstration today, we will be talking about NSO, Health Insights, Situation Manager, and Change Automation. What are these actions that will be performed for our demonstration today by these applications? NSO would deploy the service models. At the same time, it would enable proactive monitoring on the services that have been deployed. Health Insights would push all the configurations that are needed to monitor this particular service, and it would constantly check to make sure that the SLAs are met. Whenever there is a breach on the SLA, the alert is forwarded into Situation Manager. Situation Manager would create situations based on the services that are in place or that are deployed using NSO. That way, it would collect all the events from the network, but it would narrow it down saying that this situation room needs to be addressed from this particular service level. So we would tag the respective service to the situation. As Situation Manager is an AI ML tool, it would recommend actions based on the situations created to remediate the alert that is coming in and make sure that the SLAs are met continuously. This remediation is done by executing bots from Situation Manager, which would in turn trigger the playbooks which are residing on Change Automation. The KPIs, as mentioned, are linked with playbooks, so the intelligence would be fed into Situation Manager automatically from Crosswork, Change Automation, and Health Insights applications. Okay, let's see this in action in the demonstration by my colleague Farook here.
Thank you, Harsha. First, we'll discuss the workflow of the demo, which involves NSO, Crosswork Health Insights, Crosswork Change Automation, and Situation Manager. So in this demo, we are going to show that we can monitor the health of the service from day one. And the steps to do that are we first define the KPIs of that NSO service within a KPI profile, followed by the provisioning of the layer 3 VPN service. If it's successful, the layer 3 VPN service calls Health Insights to enable the KPIs. At this point, after the KPIs are enabled, Health Insights will start monitoring the KPIs of that service. And if there are any alerts that are raised, then those alerts are forwarded to the Situation Manager. The Situation Manager aggregates those alerts to situations. And it queries NSO to see if there's a correlation between those situations and any NSO services, and specifically service instances. If it is, it updates the situation information with the NSO service information. Now that we know at this point which services are affected, we can provide the remediation. The remediation involves calling the change automation playbooks. The change automation playbooks can be called from either the situation manager using bots or directly from change automation. In this demo, we are going to call the playbooks from the change automation. So let's go ahead with the demo now. So before we configure the layer 3 VPN service, we need to define what the key performance indicators are, or the KPIs that we need to monitor for that layer 3 VPN. We do that by defining a KPI profile. That KPI profile is a way to aggregate the KPIs that are relevant to a certain group. We give that a name, L3 KPIs. Let's give it a description. In our case, we're going to select two IP SLA KPIs, UDP echo and UDP jitter. Let's save that. So now that we've defined it, let's enable those two KPIs. The threshold parameters for these KPIs are configurable, so let's edit that. Let's give it more meaningful values here. And for the UDP jitter one, we will use the default values. So after defining this, we can define what happens if we get an alert on any of these KPIs. So we will select the IPSLA echo KPI, and we're going to link it to a playbook. What this means is that if we get an alert on that specific KPI, then we can execute this playbook. So when we associate it, we need to specify what the source of information is for the playbook. For the name of the device, we're going to get that from the KPI alert, and the name of the device is referred to as a producer in the playbook. The configuration that needs to be sent to the device, we are going to provide that at runtime. The other parameters, provider being NSO, which means NSO is the configuration system. We obtained this from telemetry, and the default timeout of the playbook is 1 hour. So here we see that the playbook is now tied to the KPI. So now that that's been done, let's go ahead and create our NSO service. It's a layer 3 VPN service. Let's create a new instance, my VPN 1. Specify some of the parameters for the VPN. Set the KPI enabled to true because we want to enable the KPIs. We select the devices. In our case, we are going to select 2 devices. One is router Milpitas and the other one is router San Fran. We need to specify what KPI profiles we are going to enable. As we have defined a KPI profile called L3 KPIs, we're going to use that. We can also assign multiple KPI profiles. We'll use the IPSLA, we'll change the default values. For the crosswork identification and credentials, these are correct, so we're not going to modify that. The layer 3 VPN service uses these to talk to the crosswork health insights. Let's try to go ahead and commit that. Before committing it, let's verify that the configuration is correct. For router Milpitas seems to be correct, and for router San Fran also. Then let's commit that. The configuration of this layer 3 service, we can consider that as a 2-step process. The first one being a normal layer 3 VPN, just like any other service that's configured. And if and only if that service is configured, then that service is going to make calls to the health insights to enable the L3 KPI's KPI profile. What health insights does is it turns around and calls NSO and asks NSO to configure those 2 KPIs on the 2 devices that we have selected. Now that they are successfully configured, let's go back to our crosswork health insights and check if the KPIs have been enabled. Yeah, the layer 3 KPIs has been enabled on router Milpitas and router San Fran. We set this refresh interval to 1. So now that we have configured it, the health insight will start monitoring these KPIs. So here we see that there's a green icon here, which means the configuration was successful and it has started monitoring it. And this icon below the actions column means that we have a remediation, the one that the playbook that we selected, which we can invoke if there is an alert. So here we've got a data point, the first data point. Now that we've gotten a first data point, let's go ahead and add a delay between the router Milpitas and the router San Fran so that we can get an alert on UDP echo. We do that by traffic generator. This is not part of the Crosswork portfolio. This is just an independent application which you're going to use. Let's set a delay of 300. This is a round trip delay. So now that that has been done, what we should see is during the next time interval that we get a data point, we should see a spike in our Grafana dashboard here of 600 milliseconds. And based on the thresholds, that should trigger I think we got a second one, but that was before the delay got into the picture. So here we get another data point, and it says that it's a critical alert. Now that, and the message also should get refreshed here pretty soon. Yeah, so we got this here. Now that we've gotten the alerts, all the alerts that we get, we are forwarding it to the Crosswork Situation Manager. So we've gotten this alert, and the description is now NSO service layer 3 VPN is unaffected. Now, that's a good sign that we know we can identify which service, but what's more important is identifying which specific instances of that service. So we got an alert both on router Milpitas and router San Fran, where we had a layer 3 VPN instance, and which have been grouped together to form one situation. So let's look if we have any additional information. We should have specific information related to NSO. This happens only if there's a correlation between the situation and the NSO service. So here you get more information saying the devices that are possibly affected are router San Fran and router Milpitas. The NSO service instance that is affected is myVPN1. The KPI profile that was associated with that is L3 KPIs, and the service is L3 VPN. So this sort of narrows down exactly the NSO services that have been affected by the alerts. Now this helps us in enabling the closed loop remediation. Let's enable it from the change automation because we had already tied the playbook to that. And the remediation can be of different types. For our scenario, what we are going to do is we are going to change the ISIS metric value to a higher value so that the layer 3 VPN gets rerouted. So in our case, on router Milpitas, on the ISIS IBON tag, and for on this specific interface, we're going to change the value to 100. The playbook provides the flexibility of executing in different modes. One is there if there are multiple steps to a playbook, you can define saying run it continuously, or you can single step through that, or you can create a dry run. You can also collect syslogs. And for our case, we will not collect the syslogs, and you could also schedule it. And we're going to run it right now. Apart from that, you can say what the failure policy is. What happens if that playbook fails? Do you want to abort it? Do you want to pause it and fix that scenario and continue on the playbook, or do a complete rollback so your network is in a consistent state as it was before the playbook was executed? This is the summary page, and this summary page specifies the change in the parameters, the devices, and the playbook. So here you notice that there are a playbook name, and then it's continuous mode, pre-maintenance, maintenance, and post-maintenance. The pre-maintenance, post-maintenance helps to do pre-checks and post-checks and to make sure that our network is what we expected it to be before and after. Let's give it some name and tags. These tags allow us to identify and search at a later time. So once we do that, we can run the playbook. And the playbook in our case has two steps. One is the trigger node lock operation. What that means is the change automation tries to get a lock on the device, and this is within the context of health insights. It prevents any other users in health insights from accessing that device. Once it gets that information, it will push the configuration. You could also check it from the job history. The job history gives us the details of all the playbooks instances that have been executed so far, and it goes into the details of what were the tags set, what's the status, what's the name of the playbook, what are the steps in the playbook, what are the exact configuration parameters that were sent, the execution details in terms of what's your failure policy. So this gives us a view into all the steps. So if you need to reuse it or rerun it or find out what happened when we ran the playbook, all that information will be available here. Let's go ahead and check what our status is right now. So that has been successful. So let's just go through the event log here. So this specifies that the node lock operation was enabled. It succeeded in getting the lock, and here the configuration was set to NSO to change the metric value, and that the initial metric value was 1, and now it has been set to 100. So now that it is successful, let's go back to the router here. What we should see is we saw a spike in the graph before. At this point, we should be seeing a dip in the graph. What that means is the layer 3 VPN that we had was rerouted because of the change in the metric value. So we saw that there is a dip in that graph, which indicates that our layer 3 VPN has been rerouted. The playbook that we call from change automation also exposes an API that we can use to call from any other applications. So let's call it from the situation manager itself. Now, situation manager has a collaborate tool. Each of the playbooks has an API, and we can use that API to make calls from any northbound applications. So in situation manager, we use the bot feature to call that API. And the name of the bot is ISIS metric change. And the signature involves providing 4 parameters. One is the device, which we are going to reconfigure, the ISIS tag, the interface ID, and the metric value. So let's set it to 101. These are exactly the same parameters that we specified in the change automation playbook, except for the value 101 here, we specified there as 100. So this makes a call to the change automation. So here the call was successful, and we can see the details of this call in the change automation, as the audit trail of that call is there in the change automation. Here, if you look at the tags, it says shipment, so we can recognize that this call was made from the situation manager. And this shows exactly the same sequence of steps or the events as we were executing it from the change automation itself. So it has acquired the lock, and now it's going to change the value of the ISIS interface to 101 here. So by showing it using both the change automation and the situation manager, it shows that the closed loop remediation can be done either from change automation or using the API from not just the situation manager or from any northbound applications to reconfigure the network. So that ends the demo for the closed loop automation with the alert correlation. To summarize, we can monitor the health of an NSO service by specifying the right set of KPIs, enabling the remediation change automation playbooks for each one of these KPIs, which can be triggered when we get an alert. And also, we can map those alerts to specific instances and services of NSO. Now over to Harsha for closing remarks.
I would like to touch upon the key values of our solution here. Crosswork applications are API rich, which can be easily integrated into various systems, various existing systems of your own network, and this becomes a very powerful tool in terms of network automation. You can program your service for the network using these tools with a very minimal manual intervention. Everything is predefined or learned from the tools. This in turn reduces the risk of mistakes that can be occurred during the execution phase. If you want to learn more about our Crosswork applications, here is Crosswork developer documentation page. Please take a look at it, and please do provide us the feedback. Thank you.